Hello and welcome back. Today we will be talking about polarization of light, and we will solve two past paper questions to understand this topic. Now, I must say that polarization of light is a minor topic in the AS physics syllabus. So mostly you will see multiple choice questions from this topic. I couldn't find any extensive response question from this topic in the past papers, but you never know. Maybe they can also ask, for example, to explain the phenomena of polarization of light or write a note on how this happens. So it's really important to understand, or it's really important to have a visual understanding of what polarization of light is. And for that, we will start with a simulation of polarization. So this is what polarization of light basically looks like. We have incoming light waves. In this case, we have two light waves. One light is polarized in the y direction, another is polarized in the x direction. We have our first filter, which is a Y polarizer, which means that it will only allow the light which is polarized in the Y direction to pass through it. And this is our second filter. Now, if I change our second filter to be an X polarizer, you will see that the result is no light on the right side because the incoming light is only polarized in the Y direction, and this filter is an X polarizer, which means it will only allow the light which is polarized in the X direction to pass through it. And since there is no light which is polarized in the X direction, the result is no light on the right side. And in between this X polarizer and Y polarizer for the second filter, you see that the intensity of light will decrease. So if I keep changing this angle, let's say from 90 degrees, so from Y axis straight up, we have maximum intensity of light. But if I change it towards X, you see the intensity of light or the amplitude of light, because intensity is proportional to amplitude, the intensity keeps decreasing until for X it becomes 0. Now here, I want to point out a very common misconception that students have. What they think for a diagram like this, or for example, a video or a simulation like this, what they think about this incoming light is that this light is actually electromagnetic wave for which electric field, for example, is vibrating in the Y direction, and the magnetic field is shown to be vibrating in the X direction. And after passing through the first filter, the polarizer will block the magnetic field, which is oscillating in the X direction, and it will only allow, for example, the electric field oscillating in the Y direction. This is completely wrong, okay? What you are seeing here is two electromagnetic light waves, one of which is polarized in the Y direction and one in the X direction. So for example, in between these two filters, what you see is an electromagnetic wave for which only the electric component is shown, which is vibrating in the Y direction, but it does not mean that it will have no magnetic field component oscillating perpendicular to this plane, okay? It will have a magnetic field component which will be oscillating perpendicular to it, and it will not be blocked by this polarizer. In this picture, I think you can understand the point more clearly. So we have a beam of light, and which is composed of different light waves polarized in different directions, but each single light wave has electric and magnetic field components oscillating perpendicular to each other. And after passing through the first polarizer, this polarizer will only allow the light wave which is polarized in the Y direction to pass through it. But this light which has passed, this is still a complete electromagnetic wave. It is still made up of electric and magnetic field components, and electric fields and magnetic fields will be oscillating perpendicular to each other. So polarizer don't work like this, that they will only, for example, allow the electric fields to pass and they will block the magnetic fields which are oscillating perpendicular to the electric field, okay? So I hope this point is clear. You can ask any questions if you are still confused. You can ask the questions in the comments. So having discussed the concept in detail and all the basics, we can now solve the first question. We have a lamp here and we have two polarizers, Q and P. And the lamp appears dark when viewed through P and Q. So oriented like this, we don't know whether P and Q are X polarizers or Y polarizers. But from this information that the lamp appears dark when viewed through P and Q, we already can deduce that the polarizers must be oriented perpendicular to each other. So if Q, for example, is a Y polarizer, then P must be an X polarizer, and that's why we see the lamp to be dark, right? So we don't see any light on this end. Now, what happens next? Q is rotated through an angle of 180 degrees. So imagine rotating Q by 180 degrees. After a complete rotation, for example, of 180 degrees, the Q polarizer will still be a Y polarizer, right? You can imagine in your head, rotating it by 180 degrees, you will still have a Y polarizer. But the question is, which row of the table gives the appearance of the lamp after Q has rotated by 90 degrees from its original position and then by complete 180 degrees? So by 90 degrees, if you start from this initial position, so this is our reference, this is our initial orientation. If we rotate Q by 90 degrees, the polarizer will look like this. So if Q is rotated by 90 degrees, Q and P will be both X polarizers, which means they will both allow the same light to pass through these filters, and we will see a bright light on this side. So bright is only in option C and D. Okay, now after we rotate this filter Q by another 90 degree, so it will again become a Y polarizer. So we know that if this is Y polarizer and this is X, then we will see no light here on this side, so it will be dark. And you see the dark is option C. This second question is based on exactly the same concept, so I would recommend you stop the video and try this question by yourself. The question is that we have three polarizers, X, Y, and Z. The first polarizer is oriented in the Y direction. The second polarizer, which is named Y, is oriented at an angle of 45 degrees relative to the Y-axis. And the question is that the filter Z is rotated clockwise and the intensity of emerging light from Z is measured. Which angle of rotation of Z will result in the lowest intensity of light? So we are rotating this third polarizer Z, we are rotating it clockwise, and they are asking us which angle of rotation for Z will result in the lowest intensity of light. Now, if you remember the simulation that I showed you in the beginning, and if you understood the question, this last question that we solved, you should understand that whenever you have two polarizers which are oriented perpendicular to each other, that's when you will get zero light on the other side, or the lowest intensity of light on the other side. So we just have to orient Z so that it is perpendicular to the Y polarizer, or the second polarizer. So our second polarizer right now is oriented like this. Now the question is, how can we orient Z so that it becomes perpendicular to the second polarizer? And you can see that if we rotate Z like this, then the second polarizer at 45 degree and the third polarizer will become perpendicular to each other, and they will block all of the light, right? So we will see the minimum intensity of light. Now the question is, what is this angle? So if this is 45 and we want the third polarizer to be perpendicular to the second polarizer, we need to rotate it by 45 degrees below the x-axis. But be very careful, we have to measure the angle from the starting point. Starting point is y-axis, so we have to measure this angle from y-axis in the clockwise direction. So from y-axis to x-axis, this is 90, and plus 45 gives us 135, which is option B.